So here is where matrices are going to come into play. We're going to take what we know about solving systems of equations, and instead of doing it algebraically like we have done the last couple of years in algebra and algebra 2, we're going to use matrices in order to help us. And sometimes it can be a little bit easier, sometimes it's a little cleaner, and a little bit faster potentially. All right, so before we get there, we're going to go step by step through some of the processes that we need to take or to do in order to solve a system using matrices. The first thing is writing an augmented matrix. So being able to take a system of equations written the way that we see them in example 1 and turn all of that information into a matrix that we can then start to work with. So it is pretty straightforward. We're going to take a look at the coefficients of all of the variables and the constants, and those are the numbers that we're going to use. And we get rid of essentially all the variables. The one thing we want to do is we want to make sure that all of the variables are lined up accordingly. So we want all the x's in a column, we want all the y's in a column, and then we want the constants on the other side of the equal sign. So anything that doesn't have a variable is going to go on that other side, and that's going to help us out. Okay, so here's what we do. I'm just going to look at the coefficients. Once I've got everything lined up nicely, the coefficients of those variables are going to become the elements of my matrix. So 3 is in front of x, -4 is in front of y, and then -6 is that constant in the first equation. And then right below that, I'm going to write the coefficients and the constant of that second equation. 2 is the coefficient of x, -3 is y, and -5 is the constant. So I draw a line through that matrix where the equal sign would be on the system of equations. That helps us kind of keep track of things as we start working with these matrices, but this is what we would call the augmented matrix. We took a system of equations, turned it into a matrix. All right, try B, pause the video, and then I'll have the answer up as soon as you're done. All right, here we go. Final answers down below. This was a trick question. Not all the constants or the constants were on the right-hand side of those equations. So in the second and the third equation, you got to move the 1 to the right-hand side. And then there were some variables missing in the second 2 equations. So in the second equation, we didn't have a y, which means that the coefficient of y is 0. And the third equation, we didn't have a z. So the coefficient of z is 0. We fill those spots in the matrix with zeros. So make sure you guys check how I wrote the system of equations with the columns and the variables lined up first, and then take all that information and input it into that matrix. Okay, so setting up an augmented matrix is going to be the first step in actually solving a system of equations with a matrix. Really important. We got to get that step right if we're going to move on to the next. Okay, so the next piece is going to be using what we call row operations. So when we're talking about matrices, you'll hear row operations a lot. These are the things that we can do to the different rows and how we can work with matrices. Matrices are really special. We'll do multiplication of them in the next video next week, but it's a little bit different than the math we might be used to. So here's what we can do to the rows of a matrix. We can interchange any 2 rows. That means that we can switch any of the rows as long as we take everything about that row and move it up or down. We can replace a row by a non-zero multiple of that row. All that means, in more simple terms, is that we can multiply a row by any number other than 0. So I can multiply by any number that I want in order to change those values, as long as it's not 0. And then we can replace a row by the sum of that row and a constant non-zero multiple of some other row. It's a lot of words. All that means, that third step, is that we can add or subtract 2 rows. So we're allowed to do that. We can replace a row with the addition or subtraction, the sum or difference of 2 other rows. And there's a goal here that we're trying to achieve, which we'll talk about after we get through example 2. But let's practice some of these row operations. So example 2, we want to apply the stated row operation to the augmented matrix that we are given. So let's do example A, and then you guys will pause the video and do example B. Here is the direction. We want to replace row 2 with -4 times row 1 plus row 2. So let's do the calculation first, and then we'll write the final augmented matrix. Okay, we're replacing row 2, so row 1 stays the same. That'll be the final matrix here. But -4 times row 1, let's write that out. -4 times row 1 means we're going to multiply everything in row 1 by -4. That gives us -4, -8, -12. And then we're going to add to that what row 2 is, which is 4, -1, and 2. We're going to add these two things together, and we're going to see what we get. We get 0, -9, -10. That is the new row 2. So we go back to our augmented matrix, and the final answer is this. We don't change row 1. We keep it as 1, 2, 3, and we replace row 2 with those values that we just calculated using the rule that we were given. So 1, 2, 3, 0, -9, -10. I'm going to draw that line there again to separate where the equation or the equal sign would be in our system of equations, and that is our new augmented matrix applying that row operation. So give option B a try, or example B a try. I'll put the answer up, pause the video, do it, and then check your work against mine. Okay, final answers there in blue. That is our final augmented matrix. Again, we didn't change row 1 in this case either. We just replaced row 2 with the rule -3 R1 plus R2. All right, so here's where we actually start using matrices to solve systems. They get a little tricky, and the way that you write your final answers, or the work that you show as you get to the final answer, is going to be really important. So we're going to use something called row echelon form, and the goal is this. A matrix is in row echelon form when the following conditions are met. Now, when we read them, it might be a little bit complicated, so I'll draw it out in a minute. But first condition, the entry in row 1, column 1 is a 1. So upper left-hand corner is a 1, and zeros down the column below it. Rule 2, the first non-zero entry in each row after the first row is a 1. Only zeros appear below that, and the 1 appears to the right of the first non-zero entry in any row above. It's so much wording. When I draw it out, it might be a little bit more clear. Any rows that contain all zeros to the left of the vertical bar, so to the left of what would be that equal sign, appear at the bottom. So when we look at an augmented matrix, we have row echelon form if the following is true. So let's imagine we've got a 3 by 3, and this is the bar that would separate the equal sign. Okay, and we've got 3 numbers in there. It doesn't matter what those numbers are. What matters is what's to the left of that vertical bar. So what would be on the left-hand side of all those equations? Row echelon form, this is what we're looking for. We're looking for 1s on the diagonal and then zeros everywhere else. That is it. That is row echelon form. And the wording is just way more complicated than what it looks like when we draw it out. So we don't care what numbers are on the right-hand side of the vertical bar. That actually becomes our solutions to the system. But we want the left-hand side to get to 1s across the diagonal, zeros everywhere else. So we're going to perform a bunch of row operations in order to manipulate those numbers to get the 1s along the diagonal. That is our goal. Okay, so here is where we take everything that we talked about on the front page of the notes handout and we combine it all together in order to solve a system of linear equations using matrices. So the first thing we need to do is we need to create that augmented matrix that takes the system and turns it into a matrix. And then we can apply row operations in order to get into echelon form, which is what we just talked about on the front, all those ones on the diagonal, and that will give us our answers for X, Y, and Z. All right, it's a bit of a tedious process, so bear with me. I'm going to make sure that we show our work clearly so that I can follow along. You're going to want to do the same thing in your homework. And let's get started. Okay, augmented matrix. Make sure you line all of the variables up and that the coefficients that the constants are on the right-hand side of the equal sign. First equation is actually missing a z, so we want to make sure that we include 0 in that spot where z would be. The second equation, we've got 1s for all of the coefficients and a 1 for the constant. And then the third equation is going to give us 3, 4, -1, and 13. I'm going to draw that vertical bar that's going to represent where those equation or the equal signs would be in the equations. And that is our augmented matrix. Now remember, we don't care about what's on the right-hand side of the vertical bar. We need echelon form, which means that we need 1s across the diagonal. They have to be positive, by the way, and zeros in the spaces above and below that diagonal. So on the left-hand side, 1s across the diagonal, zeros everywhere else, and we don't care what's on the right-hand side of the vertical bar. That actually will become our answers when we get to the end of this. Okay, a bit of a tedious process. here's what we're going to do. You're going to want to show every single step. It is really easy to make a computational error when you're dealing with matrices. So we're going to make sure that we write all the steps that we're going to perform so that if we have to go back and check our work, that we know exactly what we did from one step to the next. All right, here's how I'm going to show what we're going to do. First thing I'm going to do is I think I'm going to replace row 2 with -2 times row 2 plus row 1. What's going to happen there is this. We're going to see some things start to cancel out when I add these two rows together after I multiply row 2 by -2. We're going to replace that where row 2 sits right now. So row 1 is going to stay the same. I'm just going to write that out, 0, 6. And then also row 3 stays the same. We're not touching row 3 here either. We're only replacing row 2. Now, in order to do that, I'm going to multiply the original row 2 by -2 and add row 1 to that. So we get -2 plus 2 is 0, -2 plus 2 is 0 again, and then -2 plus 0 is -2. And then we get 6 plus -2, which is 4. That would be on the right-hand side of the vertical bar. Okay, so I see that I've got 2 zeros now in row 2 instead of 1, 1, 1. All right, next up, I have the third value in row 2, and that's it. I've got zeros everywhere else. So what I'm going to do is I am going to switch row 3 and row 2. You'll see why in a minute, but that's what I'm going to do next. So row 1 doesn't get touched. We keep that the same. And I'm going to switch row 3 and row 2. Okay, vertical bars here. Now, we are really close to echelon form in the third row. We just need that bottom right-hand corner number to be a 1. So the next thing I'm going to do is I am going to divide the third row by -2. So I'm going to replace row 3 with -1/2 row 3. And that's going to give me echelon form for the bottom row. And we are one step closer to getting our final answer. Okay, top row stays the same. And the only thing that changes is now the bottom row, row 3, becomes 0, 0, 1, -2. All right, I'm going to put a check mark here because that is in echelon form. Row 3 is good. If we can get the other 2 rows down to echelon form as well, then we have got our solution. Okay, next what I'm going to do is I'm going to replace the second row with the second row plus the third row. So the first row stays the same, 2, 2, 0, 6. Now the second row plus the third row is going to get us 3, 4, 0. The -1 and the 1 get added together. And then 13 plus -2 gets us 11. And then the third row stays the same. We're not going to change the third row anymore. That is in echelon form. Okay, after that, let's see, where can we go? I'm going to divide the top row by 2. So I'm going to replace the top row by 1/2 times the top row. So that's going to give us 1, 1, 0, 3. And then we get 3, 4, 0, 11, 0, 0, 1, -2. And we are getting closer. Okay, after that, let's see, what can I do? I'm going to do kind of a more complicated situation here. I'm going to replace the second row with -3 times the first row plus the second row. Okay, let's see what that looks like. We're going to take the first row as the same, 1, 1, 0, 3. The second row is what's going to change, so the third row is also going to stay the same. And we're going to take the first row, we're going to multiply it by -3 and add the second row. That's going to become the new second row. So we get -3 plus 3, which is 0. And then we get -3 plus 4, which is 1. And then we get 0 times -3 is 0 plus 0 is 0. And then we get -9 plus 11, which is 2. So we're so close, so close. The last thing we need to do is we need to get rid of that 1 there, and we've got 1s across the diagonal, 0s everywhere else. So my last step is going to be to replace the first row with the first row minus the second row. All right, across the top, we get 1, 0, 0, 1. And then the second row is going to be 0, 1, 0, 2. Didn't change that. Third row, 0, 0, 1, negative 2. Draw the vertical bar, and we've got row echelon form here. I've got 1s across the diagonal on the left side of what would be the equal sign, 0s everywhere else, and this is great. So what happens is then this. We take what's on the right-hand side of that vertical bar, and those become the values of x, y, and z. X is equal to 1, y is equal to 2, and z is equal to negative 2. Okay, pretty tedious. It's going to take a lot of practice. On your homework, I want to see the matrix as soon as you've transformed it, but also the steps that you're taking written out so that I can follow along when I am grading. All right, you guys are going to individually practice B, pause the video, give it a try. I will give you guys the fully worked out solution to that posted on the class website if you guys get stuck, but I will give you the short answer in just a moment. So pause the video, come back after you're done, and check your answers. All right, final answers for B, 4, negative 3, and 1. X is 4, Y is negative 3, Z is positive 1. That one was a little bit more tedious than part A. The fully worked out solution is on the class website under the notes handout key. So take a look at that if you guys feel like you made a mistake anywhere. And then the homework is posted on the Google Doc. Email me if you guys have questions. See you later.